Once we get into section 2.2, we're going to look at the next method for solving a system. We call this the substitution method. I'm sure it has some other names, but that's what we're going to call it. Basically, the substitution method is used when you have two things that are equal to the same thing, which means that they must be equal to each other. For instance, for this first example, it starts off with the idea that y is equal to y, because they're both the same letter, the same variable, so they must be equal to each other. Well, if you look here on the side here, we have y equal to 2x plus 3, and we have y equal to negative 2x minus 1. If y is equal to y, notice these are both y, then that must mean that if y is equal to something, and y is also equal to something else, that those things must be equal to each other. So for this first y, I'm going to substitute in 2x plus 3. And for the second y, I'm going to substitute in negative 2x minus 1. And then I'm going to do what I do when I'm solving equations and draw my line down the middle, move my x's to one side. Move my constant to the other side, and then divide both sides by 4 in this case. So I have x is equal to negative 1. Now, if you think back to the very first page where we started at 2.1, I emphasized greatly that when you're solving a system, your answer comes in the form of an ordered pair. Well, we have the first part of the ordered pair. We have to find the second part of the ordered pair. So what we're going to do is we're going to use either one of these equations. Doesn't matter which one, because you're going to get the same answer either way. I'll use the first one, y equals 2x plus 3. Now that we've figured out what x is, it's negative 1. I use that information to figure out what y is. And in this case, when I simplify, y is positive 1. So once I found x and I found y, then I have the solution to my system. What happens when you have a case like this one down at the second example? I have h equal to something, and then I have just this interesting and it's like in general form almost equation. I can still use the substitution method because I have h equal to something. I have something I can plug in for h. So I can rewrite my second sentence, leave a set of parentheses where there is an h, and substitute something in that's equal to h. The whole idea here is that I'm trying to write an equation that has one universal variable all the way through it so that I can solve for that variable and use that information to find the other one. So I have negative 10c plus 2 times 5c plus 2 times 5.5 equal to 11. Okay, so what happens if I combine like terms, my c's? If I combine these, they cancel each other out, and I end up with this phrase 11 equals 11. This is really weird, right? I don't have c is equal to something. I don't have h is equal to something. I have a true statement. 11 does equal 11, but also it's a kind of a bizarre statement. We didn't solve for anything. We just came to the conclusion that 11 is equal to 11. If you ever do a problem like this and you end up with a sentence that's true, 0 equals 0, x equals x, 3 equals 3, that is indicative that this is a system where all real numbers will work. Or in other words, we would say infinitely many solutions. Anytime you get a true but bizarre statement, all real numbers is our solution, infinitely many, which basically means that if I were to graph both of these on a graph, they are essentially the same equation written twice, just look a little bit different because they've been manipulated around a little bit, but these are the same line, and that would give me infinitely many solutions. we wouldn't be doing justice if we weren't doing some wordy problems, right? These look like they could be awful, but they aren't, because we can build equations from this situation. Let's look at the first one. A t-shirt printer charges a $150 setup fee and $4.50 per shirt for a t-shirt company with a logo printed on it. So I'm going to do this thing where I'm going to write an equation that describes how much a t-shirt company is charging. So y equals, no matter what, $150. And then we have to also factor in that they're selling the shirts for $4.50 each. So there is my first equation. The second one is a second t-shirt company, $230 setup fee, $4 per shirt for the same t-shirt and logo. Find what size order would result in the same cost from both companies. Well, we have the cost here for whatever many shirts for the first company. We have the cost here for however many shirts from the second company. We're trying to find the equilibrium where they cost the same. So we have to set them equal to each other. 150 plus 450x is equal to 230 plus 4x. So if I start by subtracting 4x from both sides, that will have me at 50 cents times x equals 230. And if I subtract 150 from both sides, that gives me 50 cents times x equals 80. And if I divide both sides by 50, 0.50, x would be 160. And remember, x represents t-shirts. So 160 t-shirts would cost the same from each company. Regardless of company. And, you know, they might even ask you how much 160 shirts would be. And if that was the case, you would have to plug this into one of my equations for x and solve for y. Go ahead and take a moment and try the second one. Remember that if you are talking about a percent, hopefully when you represent that in a math sentence, you would change it to a decimal. Same here, 0.055. Pause the video. Come back in just a moment. See if we got the same thing. Okay, so a salesperson for electronics part distributor, you're given two options for your salary structure. The first option has a base salary of $200. No matter what, $200, plus 4% of all sales. So X is going to represent sales. Y is going to represent your salary. The second one, $100, no matter what, a higher percentage of sales. Find the sales that will the sale amount that will result in the two options having the same weekly salary. I guess this comes down to what kind of salesman you are. If you're a really good salesman, you'd probably want to go for the second one. If you're like me, I can't sell anything because I hate soliciting, I'd probably want to pick the first one. Or I would just pick a different career because I hate selling things. But again, we're going to set these two equal to each other. 200 plus 0.04x equals 100 plus 0.055x. I'm going to take 100 away from both sides. I'm also going to take 0.04x away from both sides, which gives me 100 equals 0.015x. The last step would be to divide both sides by 0.015. After putting this in my calculator, I get 6,666.67. That's how much I would need in sales so that I would end up having the exact same salary. Fun. Okay, this is 2.2. So the next video is going to go on to 2.3.